All right, good morning, everyone. Welcome to section 14.1, function of several variable. Fx, this is a curve in R2. So a curve in R2 is, you can see that as a family of points. It's very important. A family of points. Z equal fxy. This would be, call it is a surface in R3. And in this class, most of the time we're gonna be dealing with surface. That is a family of curve. If you put the curve together, you're gonna get a surface. Okay, we also have a f, x, y, z. It's the function of three variables. So let's call it a density of function of some 3D solid object. Well, density function here is going to be a family of surfaces. So if you put the surfaces together, you're going to get a density. So this family okay, first thing that I want to do in this section is be able to sketch surfaces. Sketch. F x y equals z, or z equal fxy. I'm just going to use z equal fxy here. Okay, sketch surfaces. All right, what do we have here? Well, let's do an example here. Fxy equal x squared plus y squared. There are two ways to sketch surfaces. You can use either the level curve or traces. So method one, level curve. Fxy equals 0, right? Give us that 0 equal x squared plus y squared. Fxy equal 1 equal x squared plus y squared. Oh yeah, I'm gonna be using technology here because if I sketch by hand, it may look ugly as hell. I can sketch the surface by hand, but for the curve, I want you to see fxy equal 2, right? 2 equal x squared plus y squared. Now let's do one more. Okay. Okay, look at these. How nice. We have the point here. And I just have to blow this thing up so that you see it. Very nice. Yeah. Okay. Me print screen here. And the level curve, right? They get closer to each other as the value of fxy get bigger. Next thing is that you're gonna translate these level curve into three-dimensional surfaces. So how do we do that? That is what we're gonna do. I'm gonna show you guys my sketch. Okay, so you have a fx y equal to 0. That's right, it's the plane z equals 0. fx y equal 1, that is, we have a circle on the plane z equal 1. So z equal 1, you have this circle. Right? So for z equal 2, you have another circle, see? And then for z equal 3, you're gonna have another circle. My sketch might not be good. But this is what we have here. The circle here, they are the level curve, right? So this circle, this one, gonna correspond to, oh, actually, let me do the color here. So you see, I have the color, I have the same color. So for this one, right? Yes, this circle, and then the green one is this one. And the other color is this one. Oh, wrong color. Yeah, see. So if you stack up the circle, then what you have is gonna be this shape right here. We call this the surface of a paraboloid. A paraboloid. The reason why it is called a paraboloid is because of the method number 2. Here come method 2. We're going to be using traces. So what do you mean by using traces? Well, we got to let x equal to 0 and see what is going on. Right? So I'm going to let fxy equals z, because we have the x, y, z coordinate. Set x equal to 0. Get z equal y squared. Oh, shoot, this is a parabola. Set y equal to 0. Get z equal x squared. Oh, another parabola. These parabola, I'll call it traces. Z equal y squared is going to be a parabola. A little ugly here, but so this is the z equal y squared, and then for the other one, it's going to be a z equal x squared. So it's going to be this one, z equal x squared, right? And we know that you know, there's a circle up there because of the level curve, right? At z equal 3, we're going to get a circle. So that circle is going to connect these two parabola. I'm going to do z equal 3 here. And we get the same thing. We get a paraboloid using traces. The paraboloid, the name comes from the traces because the traces are parabola. And this may help you to do the quiz. Okay, 0 is equal to x squared plus y squared. Fxy equal 1. So remember, you got to square it. So it's going to be 1 equal x squared plus y squared. Fxy equal 2. This is 2 square, right? So that is how I get rid of the square root here. Three squares, x squared plus y squared. Now, see the difference between the square root and the non-square root. So that is going to be using, of course, Desmos. X squared plus y squared equals 0. Equal 1. Equal 2 square. Equal 3 square. Get smaller. Evenly spaced mean same slope, right? Same slope is exactly linear. Slope, you know, linear slope is just a straight line. A straight line. Slope is a straight line. Slope is a straight line. Okay. With this one, we can sketch out my God, I have to use the same color here for you guys to see. It's 1. Get this thing here. It's 2. I'm gonna fix it. Yeah, most likely I'm gonna have to fix this thing here. Because we know the slope is just a straight line. So let me get that straight line here, and then it will save me a lot of, yeah. Redo this thing. So and then for the last one, it's going to be 3. Yeah, what we have is a cone. Okay. And then the 2 straight lines that I drew on there, they are traces. If you let x equal 0, you get z equal to, come on, I'll do the traces there. Notice that traces are straight line. Let x equal to 0. Then z will be root of y squared, but then root of y squared is the same as absolute value of y. This is the straight line here. See, it's the absolute value, it's the straight line. Yeah. And then also y equal to 0. Z equal to square root x squared, which is absolute value x. Yeah. Straight line. Okay. Hopefully you guys are able to distinguish between the cone and the paraboloid. So if the level curve are evenly spaced out, then we're gonna have a cone. The line is linear, linear line. But if not, then let's see. Notice that level curve get closer as fxy value get bigger. We get a curve instead of line. steeper slope as z get bigger. That is very important that I want you guys to know. Right? Meaning that steeper slope and then you can see right where that trace is not going to be a straight line. The trace is going to be a curve. Right? So that's why you see down here traces, they are parabolas. Okay, gonna traces or straight line. Okay, guys, there's one more sketch that I want to do. These two surfaces, they are very useful later on. We only focus on a few surfaces though, not on every surfaces. So here come a pretty useful surface later on when we get to the chapter 15 and 16. So here come another example. Sketch domain level curve and surfaces fxy. Okay, fxy equal square root 9 minus x square minus y square. For this one, we can find the domain because of the square root. So the domain is going to be a set of value x, y, so that the square root has to be defined, meaning that 9 minus x square minus y square has to be greater than or equal to 0 for the function to be well defined. Okay, this one is the same as x square plus y square less than or equal 9. Oh, what do we have here? What we have here is very important when you get to chapter 15 and 16. When you do the volume and the mass of a 3D object. Okay, I'm gonna sketch out the domain here. Domain is x, y, so of course x, y. Huh? We have two layers. One is this circle of radius 3. And then the other one is going to be the inside of that circle. So fill up everything here. So two layers. Right? One layer is x square plus y square equal 9. This is the boundary, and inside is x square plus y square less than 9. We call this a circular disk. It is a circular disk, right? It's not a circle. Right? Just be careful. Okay. Next, in order to figure out the level curve, right? You're gonna have to set fxy equal to z and work it out to see exactly what the heck is going on here. Oh, next time if I write z, right, you automatically know it is fxy. So z equal to root of 9 minus x square minus y square, right? Z square is 9 minus x square minus y square, and you see that x square plus y square plus z square equal 9. Well, this is a sphere of radius 3. Okay. However, because the value of z is positive, right? Because z values are positive, we only have half of the sphere above the xy plane, the surface, a half sphere above xy plane. Yeah, in order to do this half sphere correctly, you're gonna have to do the level curve here. So here come your level curve. You know it is half sphere, but I'm gonna do the level curve for the sake of this thing here. Level curve, right? So to do the level curve, what you want is that because the level curve can only be on the xy plane, so you got to rewrite this as x squared plus y squared equal 9 minus z squared, right? And then from here you can do z equal to 0, x squared plus y squared equal 9, z equal 1, x squared plus y squared equal 8, z equal 2, x squared plus y squared equal 5, z equal 3, x squared plus y squared equal 0. It's a bunch of circles, not evenly spaced out. So you know that it is not going to be a cone, right? It has to be well, because of this x squared plus y squared plus z squared here, you know that it is part of the sphere. Base here is going to be z equal to 0. Let me get this base first here. That look okay, huh? And the other one is going to be this one. So z equal to 1. So z equal to hopefully it look like a half sphere. But this way it look like. You can use GeoGebra. We're in GeoGebra now. Ta-da! Let's input this sucker and sketch it. fxy equal square root 9 minus x square minus y square. Oh my God, look at this thing here. Man, look at this. You can rotate this thing and make it look very nice. Yeah. Last part, to sketch density function. Fx, y, z. Okay, let's do one. Sketch fx, y, z equal 4x square plus 9y square minus z square. In order to do this, I'm going to be using level curve though, because we know level curve. You got to get rid of one, let the function equal to a number, right? So I'm going to be using level curve, level of f, x, y, z, or anybody can fill this out. What are they?
Surfaces.
Yeah, because once you get rid of the f, x, y, z, right, when you let it equal 0, 1, 2, 3, then you're going to get a surface. Yeah. Okay, so here come let f, x, y, z equal 0, right? Okay, so what do we have here? We're going to have a 0 equal 4x squared plus 9y squared minus z squared. So what do we have here? We have a z squared is 4x squared plus 9y squared. Oh, so z is plus or minus square root of 4x squared plus 9y squared. That is very similar to the one that we just did up here. Let's say, the square root of x squared plus y squared. So you should expect to get a cone here. And this one is, of course, it will be a cone. So level curve of, now we do two-layer level curve. Of z equal fxy or curves on or two. So you know this one, level curve or ellipses. Because of the 4x squared plus 9y squared. It's not going to be a circle. You can use GeoGebra, not GeoGebra, though, Desmos, and you will see. So you're going to have an elliptic cone for the plus and an elliptic cone for the minus. So this is the one that elliptic cone z equal root of 4x squared plus 9y squared. Remember, we still have the minus one, so it's going to be down here. Elliptic cone z equal minus root of 4x squared plus 9y squared. That is only the level curve for fxyz equal to 0. We got to do fxyz equal 1, equal 2, equal 3, equal 4, equal 5, and then stack them all together. Then you're gonna get a density. Well, I can only do 2 though, running out of time. Let f, x, y, z equal 1. This means that we're gonna have a 1 equal 4 x squared plus 9y squared minus z squared. So we have a z squared plus 1 equal 4 x squared plus 9y squared. Yeah, don't bother to solve for z here. So if you have this, it is much better to do the level curve. Then you're gonna do a level curve of, well, I'm going to say level curves are well, if you let z equals 0, 1, 2, 3, 4, 5, right? You're going to see that we got our ellipses again, right? Our ellipses. Yeah. The ellipses here are very different from the cone because of the z square plus 1. So you do not get the same slope. I'm going to do two things here. We know level curves or ellipses, right? But then we also know traces or actually, let me do a few of them so that you can see. So at z equal to 0, right? You're going to get a 1 equal 4x squared plus 9y squared is equal 1, right? Oh, because of the z squared, you can have z equal -1 also. 2 equal 4x squared plus 9y squared. 2 equal 4x squared plus 9y squared. And then also do the traces. Traces are, if you let x equal to 0, then you're going to have a hyperbola. Right? Let x equal to 0. Then what do we have? We have a one equal to 9y squared minus z squared. Let y equal to 0. Then what do we get? We get 1 equal 4x squared minus z squared. These are hyperbola. So meaning that when we do the sketch, you got to be a little careful. You're gonna have to do some connection that is consistent with the level curve and the traces. So at z equal to 0, right? We're gonna have an ellipse, right? So there is one ellipse right here. Right? At z equal 1 and z equal -1, well, get the same. Actually, same thing. So I'm gonna use different color here. Oh my god. Get the same thing here. Oh. Yeah. And so on so forth. See, so now you got to connect these ellipses using hyperbolas, right? Connect them, and hopefully you remember how to sketch a hyperbola. I'm gonna read. Okay. Okay. Yeah. That look good. Just have to fit this thing and this one. Okay, what do we have here? If you look up this, it does look like a nuclear power plant, right? We call it a hyperboloid. Oh. Yeah, take a while to sketch this thing by hand though. A hyperboloid, a nuclear power plant. Yeah, that is what we use to model. We use a hyperboloid. Okay, so there are a few useful surfaces that I want you to know because we're going to be sketching them later on a lot. All the useful surfaces, only 2 of them though. Well, I want you to know the plan ax plus by plus cz equal d. This is the formula for the plan for math 1c. And then cylinder, hopefully you learn cylinder from math 1c. You can have a x squared plus y squared equal a squared, x squared plus z squared equal b squared, or y squared plus z squared equal c squared. Planes and cylinder, they are very useful in chapter 15, because in chapter 15 we're going to be doing a lot of integration, and we got to change the coordinate into cylindrical coordinate and spherical coordinate. You got to know what a cylinder look like.